Now let's see why the infinity that corresponds to the amount of the natural numbers is different than the infinity that corresponds to the amount of even numbers. So let's begin putting the natural numbers. So the natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. Then we are going to put the even numbers. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So we could say, or somebody could say, that the amount of natural numbers is infinity and the amount of even numbers is infinity. There are infinity even numbers and there are infinity natural numbers. And we could put for every natural number, we can say an even number. 1, then we say 2. 2, then we say 4. 3, then we say 6. And so on. So there is no natural number that we can say in which we could not say an even number. So there are infinity natural numbers, and for every natural number we could say an even number. So that is why people say that the infinity that corresponds to the amount of natural numbers is equal to the infinity that corresponds to the amount of even numbers. But now let's say why this is not true. And this is because here we are counting the numbers in base 10, meaning that each 10 numbers will repeat. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11, 12. So the last number is repeating. So 1, 2, 3, and then here 11, 12, 13. So each 10 numbers we repeat the sequence. This is counting the natural number in base 10. Here we could say that we are counting the natural numbers. So these are the natural numbers, but instead of in base 10, they are in base 5. Because each 5 numbers will repeat. 2, 4, 6, 8, 10, and then 12, 14, 16, 18, 20. So 2, 4, 6, 8, and then a 0 corresponding to 10 and 20. So we could say that here we are counting natural numbers instead of saying 1, 2, 3, and so on, which are counting numbers in base 10. We could say this, which we call 1, corresponds to this number. This, which we call 2, corresponds to this amount of number. This, which is 3, corresponds to this amount of number. Here, we are counting the same numbers. Obviously, 2 is greater than 1, but we are not saying the sum of all these. Obviously, the sum of the even numbers, here is 2 plus 4, is greater than 1 plus 2. But we are not saying that. We are just saying that we are counting here the same natural numbers, but instead of in base 10, we are counting them in base 5, because we could say this number is 2. We are saying this number corresponds to this. The second number corresponds to this. The third number corresponds to this. Fourth number corresponds to this. So we are counting the same natural numbers, but instead of base 10 is in base 5. Let's do it again. Here is this number corresponds to 1. This. Here, which we call 2, we have this amount of number. This is the number 3, and here we have this amount of number. This is the number 4, and we have this amount of numbers. So from here to here we have this amount of numbers. And here the same. We call this number here. This number is this, 2. Here, this is 4, but we have this amount of numbers. We have this and this, this and this. Here, this is 6, and we have this amount of numbers. This one, and this one. Here, this is 8, and we have the same amount of numbers. We have this one, and this one. This one, and this one, which is the same. This one, this one, this one, this one, and this one. So here we are counting natural numbers in base 10, which means repeating each 10 numbers the sequence. Here, when we count even numbers, we are repeating the sequence each 5 numbers, but look that is the same amount, the same natural numbers, but instead of in base 10 is base 5. So let's suppose here, from here to here, we have this amount of numbers. I don't want to say the word of how we call this number, but we have this amount of numbers, and from here to here we have this amount of numbers. But is the same. This one is exactly the same than counting this one, because these are these are natural numbers in base 10, these are natural numbers in base 5. So this is not proving, this is not proving that the natural numbers, that the amount of natural numbers is the same than the amount of even numbers. This is just saying that the natural numbers, we could count them in base 10 or count them in base 5, and that is the same amount of number. Again, we are not saying that the amount of natural numbers is the same amount of even numbers. We are not saying that. We are saying that the amount of natural numbers counting in base 10 is the same amount of numbers counting in base 5. And now let's see another way in which we can refute that the amount of natural numbers is not the same amount of even numbers. That is, we say that natural numbers is infinity. We have infinity natural numbers, and we have infinity even numbers. So if we divide the infinity, which corresponds to the amount of natural numbers, over the infinity that corresponds to the amount of even numbers, both are infinity. So we are saying that the natural numbers are isonumerous with even numbers. So this infinity is the same as this infinity. If that is true, then infinity over infinity would be equal to 1. But not. Infinity over infinity is undefined. And we could say that is undefined because the infinity that corresponds to the natural numbers is greater than the infinity that corresponds to the even numbers. Again, when we do the isonumerosity of saying or matching this one with this one, matching this one with this one, matching this one with this one, we are saying exactly the same thing. We are counting natural numbers, but instead of base 10, we are counting natural numbers in base 5. So we don't see that we are counting even numbers. We are counting natural numbers, but instead of base 10, base 5. And so because we are counting the same thing, they look like the same. Another way to refute that natural numbers are equal to even numbers is that infinity over infinity is not 1, that is undefined. See you in the next video.